Hello everyone. So in this video we will study about reciprocity theorem, but I will again and again use this term port. Okay, if you have already studied about it, you can skip to the theorem part, but if you haven't studied, I will just define the term. Okay, so basically in simple words, two terminal means one port. Okay, that's it. Like there is two terminals, I can apply a voltage here and can get a current out of it. So that means it is a one port network. Let's just assume I apply a voltage V1 here. So I will get a current I1 out of it. So that means it is a one port. Now here I can apply a voltage V1 and get a current out of it, right? Also I can apply a voltage V2 here as well and again get a current out of it or into it. Okay. So in two port network I have two ports where I can apply voltages. In one port network I have only one port. Okay. So let's just take this example. Let's just assume I apply a 4 volt here, 4 volt battery here. Okay. I am applying a 4 volt battery here. So tell me what will be the value of this current? How can you do this? If this is 4 volt, there will be 2 ampere current, and here we will have 4 and 4. So here we will have 1 ampere current. So the current here would be 3 ampere. Now in this question, what do? I apply a 4 volt here as well. Okay. So what will be the current here? This will be 2 ampere. I need to calculate this current. Now also I apply a 6 volt here as well. Okay, I am applying 6 voltage here as well. So what is the current here? 3 ampere, and 6 minus 4, this will be under 2, so 1 ampere current here. So basically this will be 4 ampere current, right? And 1 is coming from this side, 1 ampere current is coming from this side. I applied 4 volt here, got 3 ampere current. In this circuit I applied 4 volt here, got 1 ampere current, and I applied 6 volt here, got 4 ampere current. Okay, now someone will get a doubt like, what if I increase the network like this? Okay, you can increase the network like this, but still it's a one port network only. Okay, still it's a one port network only. Why so? One port network only. Why so? Because you are not applying any voltage source here. Okay, in this question you extended it, but you are applying a voltage source here. Still the current here is zero. Still there is no current going out of it because this is an open circuit. But this is not open circuit because you have applied a voltage source here. So this is a two port network. Okay. So at both of the terminals, at two terminals, here two terminals, here two terminals. So at both of the side we are applying a voltage source and getting a current out of it. Okay. So this is what we mean by port. Now let's move on to our theorem, reciprocity theorem. So let's see the statement first. So what does it say? In a linear network, so this would also be linear. So in a linear network, the ratio of response to excitation remains the same even when the position of response to excitation are interchanged. What do you mean by that? Let's just assume I apply a voltage V here. Okay, I need to change the color. Let's just assume I am applying a voltage source V1 here. Okay, voltage source V1. I am getting a current here, that is I1. Okay, now what do? I apply the voltage source this time at this terminal. Okay, and the value is different. Let's just assume the value is V2. I will get a current I2 here, right? So now what do they mean by that is V1 by I1 is equals to V2 by I2, or what you can say, or just the reciprocal of it. I1 by V1 is equals to I2 by V2. I don't need to write it, right? So I am applying a voltage source here and getting a current out of it. Okay, at the other port. I am applying the voltage source V1 at this port and getting the current at the other port. Now I am applying a voltage source V2 and getting a current at the other port. So the ratio of both of them would be the same. Okay, so this is what the theorem says. One more thing, the ratio has to be ohm or mho. What do you mean by that? Let's just assume I am applying a voltage V1 here and I am getting a voltage V1 dash here, and I am applying a voltage V2 here and getting a voltage V2 dash here. So I can't really say that V1 by V1 dash is equals to V2 by V2 dash. V1 here, V1 dash here, V2 here, V2 dash here. Now the ratio will not be same because the ratio is volt by volt. It has to be ohm or mho. That means if you are applying voltage, you will measure current. If you are applying current, you will measure voltage. Are you getting this point? Okay. If you are applying voltage, you will measure current. If you are applying current, you will measure voltage. Okay, so that's the thing. That thing you need to keep in mind. Okay, so the ratio has to be ohm or mho. One more thing, it is only applicable when the circuit has only one independent source and no dependent source. Only one independent source, like this voltage source. Only voltage source. Only one independent source and no dependent source. There is no dependent source in this network. This is a linear network. Okay, so no dependent source has to be there. So then only it is valid. Okay, there is one important point regarding this theorem. So like most of the student get it wrong many times. Okay, I will just copy the circuit. So this is the scenario. Okay, a linear network, V1 voltage, I1 current, V2 voltage, I2 current. Tell me one thing, V1 by I1 is equals to V2 by I2. Is this right? Those who have already studied this theorem, is this right? What do you think? Linear network, I need to define the nodes as well. I'm calling this A1, A2 and B1, B2. Okay, this is my A1, A2 and B1, B2. Like this is my port 1, this is my port 2. Okay, this I am calling port 1 and this I am calling port 2. Okay, and similarly this is port 1 and this is my port 2. So tell me one thing, is this correct? V1 by I1 is equals to V2 by I2. Are you sure is this correct? You tell me, is this correct or not? This is wrong. Okay, this thing is wrong. Now you will say that we have solved many previous year question by this theorem. So what you solved there was wrong. Okay, what correct is that let me tell you. Okay, let's just make a circuit C. The same linear network we are making. The same linear network it is. Okay, A1, A2, B1, B2. Now if I apply I will copy the same circuit at this side as well. Okay, let me pause it. Yeah, so the same circuit is there. Now I am applying a voltage by current at this port. So I am doing the same voltage by current at this port only. Okay, I am calling this as V3 I3 and this is shorted, right? This port is shorted. So now you can say that V1 by I1 is equals to V3 by I3. Okay, are you getting this point? This is correct. So when you were talking about response to excitation, then voltage here, current at the other point, or the current here, voltage at the other point. Okay, but here you are talking about the same port. So at the input port, at the port 1, this is port 1, this is port 2. So at port 1, if you are calculating voltage and current, you can't say my voltage by ratio at port 2 will be the same. Are you getting this point? Voltage and current at port 1, the ratio of voltage and current is V1 by I1. So now you can't go at the other port, you will say V2 by I2 will be the same as V1 by I1. No. V1 by I1 will be the same as V3 by I3 at the same port we are talking. Similarly, here I will apply V4 and will get a current out of it, that is I4. Okay, this is shorted. So here V2 by I2 is equals to V4 by I4. Okay, are you getting this point? So many times I have seen even teachers teaching this point wrong. Okay, if you are talking about voltage and current at the same port, when you are taking the ratio, the other network should have the voltage and current at the same port only. Okay, are you getting this point? And this V1, let's just call this current as I dash and this current as I double dash. So now I am talking about V1 by I dash. So it will be equals to V2 by I double dash, because we are talking about two different port now. The voltage is at port 1 and the current is at port 2. So if I apply voltage at port 2, the current at port 1. Okay, interchanged. Voltage by current. Now voltage by current. Are you getting this point? If both the quantities are at same point, then the port can't be changed. V1 by I1, then V3 by I3 at the same port. Now if by V1 by I1, V1 by I dash, then V2 by I double dash. Okay, so this is correct. So just see the picture once again and get your facts clear. Okay, get your concepts clear. I hope concepts are clear to you now. Okay, I have seen many times students, even the student and even the teachers teaching this concept wrong. Okay, now I hope it is all clear to you. Okay, voltage and current at same port, voltage and current at same port, voltage and current at different ports, voltage and current at different ports. That's it. Okay, let's jump on to the example, a very simple example. We will prove all there are two statements, this one, and this one, three statements. We will prove all the three statements in this example only. Okay, you will get to know. Okay, so let's just assume I apply 7-volt battery here. Okay, and I am measuring the current in this line. I think I should measuring the current here. Just find out the current. What will be the value of current? 12 and 6 will make it 4. 4 and 4. This will be 1 ampere, right? Let's just call this current as I dash. So I dash would be, this is 1 ampere, so I dash would be 6 by 18 into 1. That means it would be 1 by 3 ampere. Now this is the same network, right? This is the same network. Now what I am doing is that I am applying double of the voltage, 14 volt, and will measure the current at this side. Now tell me one thing, if 7 volt 1 ampere, 14 volt 2 ampere, tell me, 7 volt 1 ampere, then 14 volt 2 ampere current. No, voltage and current at same point, then voltage and current at the same port only. If voltage current at same port, if I had applied 14 volt here, I would have gotten 2 ampere current here, that's for sure. But I am applying 14 volt at the other port, so I can't really say this current would be 2 ampere. This current would be something different, that we will see. But I am applying 7 volt here and measuring the current here. So that was 1 by 3 ampere. Now if I am applying 14 volt here, what will the current here? 7 ampere will give me 1 by 3 ampere. 14 volt will give 7 volt will give me 1 by 3 ampere. 14 volt will give me 2 by 3 ampere. And let's find out. 6 and 3 will give me 2. 2 plus 12, 14. That means 1 ampere. Okay. Here as well I am having 1 ampere current. Okay. This current and this current, both are not same. So this thing that I showed here, V1 by I1 is not equals to V2 by I2. Okay. V1 by I1 is not equals to V2 by I2. That is proved here. Right. Now tell me the value of this I double dash. I double dash is equals to 1 ampere current will be divided between 3 and 6. So it would be 6 by 9 into 1. That means it would be 2 by 3 ampere. Okay. Okay. So here what do you see? 7 by I dash is equals to 14 by I double dash. Okay. Are you getting this point? And one more thing, 7 by 1 ampere is not equals to 14 by 1 ampere. This is also proved. Right? So are you getting this point? Okay, you have to keep this in mind. I hope so you learned something new today. Okay, this you need to keep in mind. This also you need to keep in mind. Okay, let's solve the questions now. Very interesting problems will be there. Don't skip this part. See all the questions. Okay, we will cover a lot of things here. This is a simple question. This is one network, 10 volt here, 2 ampere current you are getting here. If you are applying minus 20 volt here, how much current you will get? Tell me the value quickly. 4 ampere? Wrong. It would be minus 4 ampere. 10 ampere is giving the current like this, 2 ampere. Minus 20 volt. That means the positive terminal is at the lower side. So it will give me a current of 4 ampere in this direction. So the current of 4 ampere will be given in this direction. So the value of I would be minus 4. Or how you can see, 10 by 2 is equals to minus 20 by I. So I would be equals to minus 4 ampere, right? अरे 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 ये क्या हो गया? 10 by 2 5. Yeah, fine. So I is equals to minus 4 ampere. Let's move on to the next question. That's a very good question. Also, we will cover one more thing here. Okay, so 12 volt is applied here, 4 ampere and 2 ampere. This is given to you. Okay, and you have to find I. Okay, yeah, this is given. You have to find I. So this circuit you need to consider. Okay, so this is the circuit. I will just copy it. Okay, so what do you think? What should I do? I should apply superposition theorem. Apply superposition. First I will see the effect of 30 volt and then I will see the effect of 6 volt, because here only one source is considered, and while applying the reciprocity theorem you have to consider only one source at a time, right? I wrote this thing. There has to be only one voltage source, right? When there is only one independent source and no dependent source. Okay, so only one voltage source you have to consider. So I have to apply superposition theorem now. Okay, so I will apply the superposition theorem. Considering only 30 volt. Okay, considering only 30 volts, and this current would be called I1. So for 12 ampere there was, for 12 volt there was 4 ampere, and the port is also same. Look here, 12 volt 4 ampere, now 30 volt I1. Okay, the port is same now. Okay, 12 volt 4 ampere, 30 volt, and what will be the value of I1? Tell me. For 12 it was 4 ampere, so 1 by 3. So for I1 would be 10, or how you can say 12 by 4 would be equals to 30 by I1. So I1 would be equals to 10 ampere. Okay, now what you will do? You will consider only 6 volt. Right? And this current would be I2. Considering only 6 volts. Okay, now tell me one thing. If 2 volt was there, 2 ampere, sorry, 12 volt was there, 2 ampere current was this side. If 6 volt is here, how much current would be there? In this side, here, how much current would be there? 1 ampere. Or how you can write 12 by 2. 12 by 2 would be equals to 6 by minus I2, right? Because I2 direction is this, but we are getting current in this direction. 12 volt here, current in this direction. So 6 volt here, current in this direction. Okay, so I2 value would be minus 1 ampere. Okay, so I will keep it in this one box as well. Now tell me one thing. Can you tell me what will be the value of current here? 12, 4. So 6, 2 ampere. Is this right? No, this is wrong. Why so? Because the ports are different. This is the input port. 4, 12, 4. 6 need not necessarily be 2 ampere, right? Because we have seen in this example 7, 1, 14, 2 ampere. No, 1 ampere only. Okay, so this is one basic thing that you need to keep in mind. Okay, let's just assume if someday gate ask you this question, what is the value of current? What will be your answer? We don't know, right? This is the answer, because we don't know the current here. Okay, so 2 ampere is not the current. So now what is your final answer? I is equals to I1 plus I2. That means 10 minus 1. That means 9 ampere. Okay, this is the final answer. So in exam, this question will be solved very quickly. You will see 12, 4. Okay, apply superposition because only one source will be there. So 12, 4, 30, 10. Okay, 10 ampere current. Okay, now I will apply 6 volt here. So 12, 2, 6, 1. 10 minus 1, 9 ampere. Okay. Now I will tell you one interesting approach for this question. I guess I need to add a page. Okay. Method 2. I will just copy the circuit. So this is our circuit. Okay. So forget about the what was the question. If this circuit is given to you, can you think of network N? Try thinking of network N. Any network you make, these conditions would be satisfied. If you apply 12 volt, there would be 4 ampere current, and here we will have 2 ampere current. This has to be satisfied. Try thinking of network N. Try thinking of network N. How would you think? Tell me one thing. Here the equivalent resistance should be 3 ohm, right? Okay. This one thing you know, and one more thing you know, like if 4 ampere current is going this way and 2 ampere current is going in a short circuit part, that means the rest of the 2 ampere current should go here. So if I make a T network, if I make a T network or star network, I can make a network like this. Okay. I will make a network like this. Okay. 4 ampere current is going this way. Okay. 4 ampere current is going this way. Now I am applying a 12 volt battery here. Okay, this is what we are doing. 12 volt battery here. Applying a 12 volt battery here. Okay, and measuring the current this side. 12 volt battery here, measuring the current this side. If this is 4 ampere, this is 2 ampere. So this has to be 2 ampere as well. So both of the resistance has to be same because the current is divided equally. So let's just assume if I am making this resistance as 4 ohm, this resistance has to be 4 ohm as well, right? And 4 and 4 will give me 2. 4 and 4 will give me 2. So this resistance has to be 1 ohm, so that 4 and 4 will give me 2. 2 plus 1, 3. So 12 by 3, that means 4 ampere current. Now this 4 ampere current will be divided into two parts, 2 ampere and 2 ampere. Are you getting this point? So whenever these kind of question they ask na, always think about T network. Okay, because in T network you can get a two port. In T network there will be two port. You can think of pi network as well, like this. In pi network as well, or star delta we call it delta and we call it pi as well. We call this star as well and we call it t as well. Okay, so you can think of this network as well, right? You can apply a voltage source here, you can get a current. You can apply a voltage source here, you can get a current, or you can short circuit it as well. So you can think of this network as well, but I prefer thinking about this T network. Okay, I guess thinking about this network would be more easier. I feel so now. I feel like this because yeah, it would be more easier, I guess. So you can think of this network as well. Otherwise, you can think of T network as well. Okay. So this is how I thought. 4 ampere is getting divided into two parts. 2 ampere, 2 ampere. That means the resistance has to be equal. So 4, 4, I made the assumption. So 4 and 4, I made the assumption. So the resistance is giving me 2 ohm. So there has to be 1 ohm so that there would be 4 ampere current because we are seeing a 3 ohm resistance from here. Okay. So that's how you can think of the circuit. Now this will be your network N. Okay, I think I should use a different color. So this would be your network N. This is your network N. Okay, now what was the question? Now just take the same circuit and just replace it with the, here I am applying 30 volt and here I am applying 6 volt. So this is my circuit. Okay, this is my network N. At one side we are applying 30 volt and at the other side we are applying 6 volt, right? Six volts. Okay, this is 1 ohm, this is 4 ohm, and this is 4 ohm. Okay, now you need to find this current, I guess, right? This is what they asked. They found they asked to find the value of this current I. So you need to find this current I. Okay, you can simply find it. How? You can find it simply by applying nodal analysis. So V minus 30 by 1 plus V by 4 plus V minus 6 by 4 is equals to 0. So 6V is equals to 4, here will come 4, 120, 120, 126. Okay, so just solve it and you will get the value of I is equals to 9 ampere only. Okay, you can solve it, you can get the value of I. Okay, I just needed to tell you the approach. Okay, so this is the approach you can go with. Okay. Okay, so let's see the next question. Actually, there was a break in between. So in this question, you need to find the value of current I. So this is also a different kind of question. So two ways of solving. First is that you can predict the circuit. Okay, it is not that tough to predict the circuit. You can predict the circuit. So I will tell this method as the second method. Okay, first we will think the concept. Okay, so in this question, you need to find the current I. So can you apply the theorem now? Reciprocity theorem. No, you can't apply the theorem because the network is same. It has to be resistive network or linear network. They can write linear network. Okay, not just the network. It should be defined that it is a linear network. So now the thing is that the network is the same. Okay, but here we have short circuit and here we have 4 ohm resistance. That's the issue here. Okay, network is the same, but there is an issue. Okay, so what would we do? Let's just pick the circuit B. Let's just pick it. Okay, so this is our circuit, right? You need to find the current I. What you can do, you can find multiple things here. You can find VTH, you can find RTH, or what do we call RN, and you can find IN, Norton current. You can find Norton current, or we call it sometimes ISC as well, short circuit current. You can find Norton current, you can find Thevenin resistance, or Norton resistance, you can find Thevenin voltage. So if you find these many things here, you can replace this complete circuit, this much of circuit, by VTH and RTH, or ISC, IN. IN and RN. You can replace this complete circuit by VTH, RTH, or IN or RN. Okay, so that's the thing we will do. We will try to find VTH, RTH, and ISC. Two of the things will work. If we find two of any one, we can find the third one. So first first we will find ISC. Okay, so we will find ISC now. Okay, short circuit current. So tell me, what do we need to do for finding short circuit current? So at any node, if we are finding short circuit current, what do? We simply short circuit that, right? We don't do anything with the dependent current source, right? When we are finding VTH and when we are finding ISC or IN, when we are finding Thevenin voltage and when we are finding Norton current, we never do anything with the independent voltage source. So this will remain the same. Okay. Simply this thing will be replaced with short circuit. Okay. Now tell me one thing. If there is 30 volt, what would be the current? If there was 10 ampere here, if there was 10 volt here, the current was 2 ampere. Now if 30 volt is here, what would be the current? 6 ampere, right? 10 by 2 is equals to 30 by I. So I would be 6 ampere, right? So this is over, this I would be your ISC. So this is our short circuit current or Norton current. This is our Norton current, right? Actually, Norton current is written by IN, but I have this habit of writing it as ISC. Okay, so just bear with it once. If I had applied 10 volt here, I would get 2 ampere at the other node. If I am applying 30 at the other node, I would get 6 ampere here. So my ISC is 6 ampere. Now try finding RTH. How will you find the RTH? Copy the same circuit. Just do the things that you need to do. That's it. And why we are applying this method in this circuit? Because we can't really apply the direct theorem. Neither we can apply superposition. We can apply superposition with the resistor? No. We can only apply VTH, RTH, this concept, right? So that's how we need to think. Okay. Now what we can do? We can find the RTH here. Okay. So while finding RTH, what do? We first open circuit it, then apply a voltage VDC and get IDC out of it, right? We apply VDC and get IDC out of it, right? Also, what do we do with the dependent source? Sorry, independent source. What do we do with the independent source? We will nullify the effect. So this will simply be replaced with short circuit. So now this is our circuit. A network, a voltage source and current, and short circuit. What was given to us? Tell me one thing. What was given to us? This thing was given to us, right? This was given to us. Just copy it here. This was given to us, right? What is my RTH? My RTH here is VDC by IDC. Isn't it the same kind of circuit? This was given 2 ampere, but that's not a matter of fact here. 2 ampere, that's not a matter of fact. This was given to us. A linear network. I am applying VDC here and trying to find the IDC. If I had applied a voltage of 10 volt, I would have get a current of 5 ampere. I told you one thing about RTH. No matter whatever the voltage you apply, let's just assume you apply 1 volt and you get a current equals to I. So what will be your RTH? 1 by I. If you apply 10 volt, you get a current equals to I. What will be your RTH? 10 by I. If you apply a current source equals to 5 ampere and you get a voltage of V, what will be your RTH? V by 5. Right? Now I am applying a voltage of 10 volt, I am getting 5 ampere current. Both are same circuit, right? Both are similar. This is given. This is given to you, right? Both are identical. By this given circuit, look, the same thing is there. I have applied a battery of VDC and getting a current of IDC. So if I had applied a battery of 10 volt, I would have got a current of 5 ampere. So what is my RTH? My RTH is 2 ohm. So your simply ISC is 6 ampere and your RTH is RTH, or I can call it RN. Okay. So basically your, now let's just take this circuit. Now this circuit, I will just copy this circuit there. Okay, let me copy. Now this circuit can be replaced with a simple current source. What will be the direction of current source? Upward. Why so? Because here the current direction was this. So it has to be like this so that it flows like, we are replacing it at this side. So it has to be something like this, that the current should flow in this direction. So it has to be upward, right? So that's why it is upward. Okay. What was the value of ISC? That was 6 ampere. Right? And what was RN? That was 2 ampere. And now here we had 4 ohm resistance, right? Here we had 4 ohm resistance and we needed to find the value of I. So you just replace it with the 4 ohm resistance. So tell me what will be the value of I? I would be 2 ampere, right? 2 by 6 into 6. That means 2 ampere. Did you get this point? We just saw the question. We needed to find the value of current I. We just saw the question. We thought we can't really apply the reciprocity theorem directly. Okay. We can't really apply the superposition theorem directly. Okay. So what do we need to do? Now we have to find VTH, RTH. First thing we can do is that we can think of the circuit. If we want to go by the concept, then we will try to find VTH, RTH and ISC. So I first thought of finding ISC. Why so? Because this circuit looks like that it can give me short circuit current. Kind of it gives me a feel. Okay. So I thought of finding ISC. So what did I do? This is my load now because I have to find the current in this one. So this is my load. I just short circuited the node. So when I draw this final circuit, I got to know this is similar to this kind of circuit. So 10 will give me 2 ampere. So 30 will give me 6 ampere. So ISC is my 6 ampere. Now I need to find the RTH. For finding RTH, what do I need to do? Open circuit it. I apply VDC and get IDC out of it and short circuit the 30 volt. Short circuit this 30 volt. So when I did like this, I got to know this circuit is similar to the given circuit. So when we saw, if I am applying at this node, if I am applying 10 volt, I am getting 5 ampere. That means my RTH has to be 2 ohm. So I just replaced my circuit with 6 ampere and 2 ohm. So this was the replacement, right? This is how this much of circuit was replaced. This is how this much of circuit was replaced. No, not this much. This much of. Okay, this much of circuit was replaced with the current source of 6 ampere and a resistance of 2 ohm. So finally my current in 4 ohm resistance is 2 ampere. So that's how we solved it. Secondly, you can think of the circuit. Okay. Try thinking of the network. So I guess you should do it on your own because I have told you how to think of the network. Try thinking of the network. What you will think? You will think about the T network. Okay. 5 ampere current is coming. So total resistance we need is 2 ohm. 5 ampere is coming, a 10 volt battery is there. So we need a 2 ohm resistance here, right? So we need a 2 ohm resistance. So how we can think? We need a 2 ohm resistance and 5 ampere should be divided into 2 ampere and 3 ampere. Okay. Let's just make something like this. 5 ampere should be divided into 3 ampere and 2 ampere. And you have a battery of 10 volt here, right? This is this is how your circuit should look like. And this would be your network. Network would be a T network. Okay. 3 ampere and 2 ampere. So what would be the resistance? This should be 2 ohm. This should be 3 ohm. If 5 ampere current is going this way, okay, this would be shorted and this will also be shorted, right? So tell me, if 5 ampere current is going this way, how much current will go in this direction? 3 ampere. And how much current will go in this direction? 2 ampere, right? This should be 2 ohm in inverse proportion. 3 and 2 will give me how much resistance they will give me? 3 into 2 by 5, 6 by 5, 1.2. 3 and 2 will give me 1.2 resistance. Okay, both of them will give me 1.82. I total need, these two will give me 1.2. I total need 2 ohm resistance. So it has to be 0.8 ohm, right? I total need 2 ohm resistance. These two are giving me 1.2. So it has to be 0.8 ohm. And I have a battery of 10 volt here, right? So all these things are satisfied. 10 volt battery, 5 ampere current is going that way, 2 ampere current is going that way, and 3 ampere current is going that way. So what is my network? This is my network, right? This is my network. Now simply replace this network in the given question. This was the given question. Just replace it there and you find the value of I. So I have to add a page, I guess. Find current in 4 ohm, right? This is 4 ohm given here. And what was my circuit? 0.8 ohm this side. Here I had 2 ohm, I guess, 2 ohm, and then I had 3 ohm. Here I had 2 ohm, then I had 3 ohm. In this question, there was 30 volt battery, right? This was the 30 volt battery there. Okay, 30 volt battery, and all of them are shorted, right? So now by simple network analysis, you can find the value of current I. Okay, by simple network analysis, you can find the value of current I, and that would become 2 ampere. Actually, I forgot to put it in the box. This is my final answer, right? So by simple network analysis, you can find the value of I. It would become 2 ampere. Okay, solve it on your own. This is a very easy question, not very tough. Okay, we're going to apply nodal here. V by 4.8 plus V by 2 plus V minus 30 by 3. Then you will get the value of V. V by 4.8 will be your value of I. So it will be 2 ampere. Okay, so this is how you can solve the question. Okay, let's move on to the next question. We will try avoiding this method, okay, in the exam, because this doesn't really give you intuitions, right? You are just solving it and thinking about the circuit, but this is the real method. Like, yeah, if you solve it by this method, you will feel very good, right? If you solve by this method, ISC, and like if the question doesn't even click, if there is nothing clicking, then you can think of the circuit, right? But if you can click, if there is in the exam, if you can think of the circuit, if you can think of this method, then you should solve by this method only. Okay, let's move on to this question. In this question, this figure is given and question is asked in this figure. Okay, now we should have written linear network, right? This is a linear network. Okay, so the short circuit test of port 2 network shown in the figure 1. Okay, you need to find the voltage across AA dash. Oh, this is AA. Okay, we should have written AA dash. AA dash. We need to find the voltage across AA dash. So what do you think? What voltage they are asking? What do you think? What it is? AA dash. What do you think? What is? Isn't it a Thevenin voltage? Right? They are asking about Thevenin voltage only. Open circuit voltage they are asking. What is open circuit voltage? Thevenin voltage. Basically, they are asking Thevenin voltage only. Asking Thevenin voltage only. What is Thevenin voltage? Tell me. You can't really find directly Thevenin's voltage, right? Thevenin's voltage is short circuit current into RTH. So first my task is to find ISC, then my task will be to find RTH. Okay, so I will just copy this circuit and we'll find the value of ISC. First we will find the value of Norton current. Okay, actually I should written IN. Okay, I should have written IN, but let's just be. We will find the Norton current here. Okay, at this terminal we will find the Norton current. This current we will find. So tell me what will be the value of ISC. 20 volt here, 2 ampere. 10 volt here, 1 ampere. 20 volt giving me 2 ampere this side. 20 volt giving me 2 ampere this side. If I am applying 10 volt here, it will give me 1 ampere this side. Right? 10 volt here, ISC would be 1 ampere. Or what do I need to write? 20 by 2 is equals to 10 by ISC. So here your ISC would be 1 ampere. Right? So my ISC is 1 ampere. Now I need to find what? RTH. Okay. So let's just make the circuit for RTH. Copy it. For finding RTH, first thing, short circuit this, because there is no dependent source allowed when we are finding RTH. No independent source are allowed. Okay. So independent source is gone. So now what will I do? I will just apply a VDC here and get IDC out of it. Right. So my RTH would be VDC by IDC. Now what is given to me? This circuit is given to me. Isn't it the same? Apply 20 volt, get a current, and the other part is short circuited. So isn't it the same? The same kind of network is there. So if I had applied 20 volt, I would have get a current of 10 ampere. So 20 by 10. So that means my RTH is 2 ohm. Okay. So from here, what do I see? My VTH would be 2 into 1. That means 2 volt. I hope you are getting a very clear concept this time. Okay. I have seen like many students doesn't even understand. They just think that, okay, V by I, 2, RTH is 2. Okay. Now what will be my ISC? ISC, okay, 1 ampere. That's it. 10, 2. The real concept is this. First you make the circuit. Okay. If you make the circuit, you will understand how we are relating it to the given circuit. Okay. So you have to make the circuit first. Like even I have seen like this reciprocity theorem is not taught that well in gate industry. So I hope I have made a change here. Okay. So I hope you have understood the concept very clearly now. 20 volt 2 ampere, 10 volt 1 ampere ISC. Okay. For finding RTH, what do I need to do? I will pick this circuit first. Okay, I am picking this circuit. For that, I will apply VDC here and get IDC out of it, and I will short circuit the 10 volt. So I am short circuiting the 10 volt VDC by IDC. So I can assume if my VDC is 20, my IDC is 10. So 20 by 10, my RTH is 2 ohm. So I have RTH, I have ISC. So my VTH would be 2 volt. So this is the correct approach. Okay, so this is my final answer. Let's move on to next question. This question. Try thinking of it, what you would do if they had asked you this question in your exam. First thing I would think, reciprocity theorem. Can you apply reciprocity theorem directly? Directly we can't apply. 1 ohm here, 3 ohm here. Gone. Second thing, I will think of what? I will think of superposition. Only one voltage source is there, different resistance, no meaning. Superposition can't apply. Try finding VTH, RTH, ISC, IN, anything. Can you find? Let's just assume I need to see this circuit, like, because this is where I need to find. Let's assume I am trying to find VTH here, not here. Yeah, here. I am trying to find RTH here. what would I do? I will apply a voltage VDC and get IDC out of it, and then no meaning actually, no meaning. I can't really find RTH here. Right? There is no meaning of applying VDC and get IDC out of it when like the resistance is different. Here 3 ohm, here 1 ohm. In previous questions, what was the different thing? There was no resistance mentioned here. Like this was the reference figure. No resistance was there. This was the reference figure. No resistance was there. In this question, this was the reference figure. No resistance was there. So there was no resistance mentioned in the reference figure. But this time we have a resistance in the reference figure. So this question actually becomes easier if you just think it. Think about it. 8 ampere current is going. There is a network that is eating up 4 ampere current and you are getting 4 ampere current in the final. So what should be the network? Think of the network. Think of the network. 8 ampere current is going this way. This is actually a very interesting question. 8 ampere current is going this way. There has to be some resistance, right? Which will eat up the current. And then there is 1 ohm resistance that is taking, this 1 ohm resistance is taking 4 ampere current, right? And 8 ampere current is coming from this side. 8 ampere current is coming from this side. 4 ampere current is being eaten by this. So here also we will have 4 ampere current. So this would be 1 ohm resistance only. So what is your network? Your network is simply 1 ohm resistance, nothing else. Okay. Just replace this network by 1 ohm resistance. 8 ampere current, 4 ampere that way, 4 ampere that way. That's it. So just replace this network by 1 volt. Sorry, 1 ampere, 1 ohm resistance. Okay. Just replace this network by 1 ohm resistance. One ohm and this is 3 ohm. You need to find the value of Ix. So what will be the value of Ix? Ix would be 6 upon, what is the equivalent resistance of 1 parallel 3, right? So it would be 6 upon 3 by 4. So it would be 8 ampere, right? Ix would be 8 ampere. Did I solve it right? Ix would be 8 ampere. The same I am getting. 4 ampere, 1 ohm resistance, 1 ohm resistance. 3 and 1 will give me 3 by 4. So 6 upon 3 by 4. Yeah, 6 upon 3 by 4. So it will give me 8 ampere only. Yeah, that's fine. My final answer is 8 ampere. Okay, so that's it about the reciprocity theorem. No other question is left. So if there are any other question left, we will see in the assignment. Okay, so I hope you have understood the concept. Whenever you see a different circuit and you are asked to find some current in the other circuit, what you will do? You will think of multiple options. How? Finding, first you will see if I can directly apply the reciprocity theorem. In the first example, we directly applied the reciprocity theorem. In this example, directly applied the reciprocity theorem, nothing else. Then, in this example, we tried superposition theorem. In the next example, what did we see? We, in this question, we see that we can think of finding VTH, RTH and ISC. Okay. In the next example, we were asked to find VTH only. So we found ISC and RTH. In the next example, we got to know that we can't really apply any method. So we have to think of the circuit only. So we directly think of the circuit and the circuit was 1 ohm resistance only. So we just replaced the circuit with the 1 ohm resistance and found the value of Ix. The value of Ix was 8 ampere. So these are the methods. Okay. So I hope you have, this concept is very, very clear to you. This is a very important concept and like this is not really clear to all the students. Many times I have seen like Thevenin's is clear, superposition is clear, maximum power transfer is also clear. Like there is one more topic that is not that much clear in maximum power transfer that I will teach you. But this reciprocity theorem is like many times I have seen it is not that clear to students. So now I hope the concept is crystal clear to you. Okay. So if you have, if you find this video helpful, please do put a comment or do like the video. Okay. Thank you very much.